Rain starts, traffic tightens, and you flick the stalk like you've done 1,000 times. Nothing. No sweep, no twitch, not even that tired half move. If you're here because of windshield wipers not working on Suzuki Swift, the worst part isn't the repair bill. It's the uncertainty. From the driver's seat, a blown fuse, a bad relay, a dead motor, a stripped wiper arm, or a linkage that popped off can all look exactly the same. The glass stays dirty and you can't see. And that's why people waste money. They replace the motor because wipers don't move, then discover the real problem was a loose crown or a seized pivot that killed the new motor too. Or they swap a fuse, it blows again, and now they're stuck in the rain with a bigger electrical problem brewing. So here's the goal: in about 10 minutes of smart checking, you can usually prove which side of the system failed. Power supply, control side, motor, or the mechanical linkage. Not guess. Prove. First, lock down the exact symptom, because the symptom is a clue. If absolutely nothing happens when you turn the wipers on, no movement, no sound, no change in engine note, think power or control. Fuse, relay, switch, wiring, ground, or the motor not receiving power. If you hear the motor humming or straining but the arms don't move, that's almost never electrical. That's mechanical: a linkage disconnected, a crank arm loose, or the wiper arm spline stripped so the arm just sits there while the shaft turns. If one speed works but another doesn't, that often points away from the fuse. It can be the switch, the resistor/control side, or an internal motor circuit depending on how the car is designed. The key is, partial function usually means the system has power, and the failure is in control or a specific circuit. If the wipers stop mid-sweep or park in random places, that's a classic park circuit clue. Wiper motors have a self-parking function so they return to the bottom when you turn them off. When that circuit fails, you get weird behavior that looks like a bad switch but isn't always. If the wipers work intermittently, especially after a bump, or only when it's very wet or very dry, think connection, corrosion, or a worn switch. Intermittent faults love to hide during testing, so you want tests that load the circuit, not just voltage is present. Now, before you touch anything electrical, do the 2 fastest external checks. They sound too simple, but they catch a surprising number of dead wipers cases. Check for physical jam. Ice, packed snow, a stuck blade, or a blade that's wedged under the edge of the hood can stall the system. If the motor tries to move and can't, it draws more current. That can blow a fuse, overheat the motor, or pop a linkage socket. If it's freezing where you are, don't keep cycling the switch. Free the blades first. Then check the wiper arms themselves. Grab the arm near the base and gently try to move it. You're not trying to force the linkage, just see if the arm is obviously loose on its spline shaft. A stripped spline can make the arm slip, so the motor and linkage move but the arm doesn't. Sometimes you'll see one arm moving and the other sitting still, which screams arm spline or linkage issue, not electrical. If those quick checks don't solve it, you move to the fastest electrical path. And this is where most people go wrong: they start replacing parts in the most expensive direction. Motor first, then switch, then maybe it's wiring. Flip that. Start with what's easiest to verify. When you're dealing with windshield wipers not working on Suzuki Swift, the first electrical question is simple: is the wiper circuit getting power, and is it able to deliver that power under load? Start with the fuse, but do it intelligently. Find the wiper fuse in the fuse box. Depending on the Swift's year and market, there may be more than one fuse involved, one for the wiper motor, another for the control side, sometimes a shared fuse with the washer pump or body electronics. If your washer pump also stopped at the same time, that's a hint they share a circuit. If the washers still work but wipers don't, that doesn't clear the fuse completely, but it nudges you toward a more specific wiper side issue. Don't just look at the fuse and call it good. A fuse can crack in a way that's hard to see. If you have a test light or multimeter, check it. And if it's blown, don't celebrate and stop there. A fuse is a symptom. It blew for a reason: a short to ground, a motor drawing too much current, or a mechanical bind that overloaded the system. Here's a practical way to think about it. If you replace the fuse and it blows immediately the moment you turn the wipers on, you likely have a hard short or a motor that's internally shorted. If it blows only when the wipers are trying to move the arms across the glass, especially in heavy rain or after snow, suspect mechanical binding or seized pivots causing overload. If it never blows but the wipers still don't work, you're back to control, relay, switch, wiring, ground, or motor failure without a short. Next, the relay question. Some cars use a wiper relay, some integrate control into a module. If your Swift has a relay you can access, you can often feel or hear it click when you switch the wipers on. No click doesn't automatically mean the relay is bad, it could mean the relay isn't being commanded, or it has no power feed. But a click is useful, it suggests the switch and control side are at least doing something. If you can swap the relay with another identical one in the fuse box for a quick test, that's a valid move, as long as you're sure it's the same type. But don't get stuck in relay roulette. The real proof comes at the motor connector. The motor connector test is the moment everything becomes clear. You're trying to answer two questions: do you have power arriving at the motor when the switch is on, and do you have a solid ground? Accessing the wiper motor usually means opening the hood and looking near the base of the windshield, under the plastic cowl area. You may not need to remove the whole cowl just to reach the connector, depending on the layout. If access is tight, take your time. Breaking plastic clips creates a new problem. With the connector plugged in, back probe if you can, or carefully test at the connector without damaging it. When you turn the wipers on, you should see battery voltage on the power feed. But here's the trap: voltage with no load can lie. Corrosion in a connector can show you 12 volts on a meter, but the moment the motor tries to draw current, the voltage collapses. That's why a test light is sometimes better than a multimeter here. A test light puts a small load on the circuit. If it lights bright and steady when the wipers are commanded on, that's a stronger sign the feed can actually deliver power. Now check ground. A bad ground can mimic a dead motor perfectly. If the power feed is present but the ground is weak, the motor won't run, or it will run slowly, or it will run only sometimes. Grounds fail from corrosion, loose bolts, or water intrusion. If you can safely run a temporary ground jumper from the motor housing or ground wire to a known good chassis ground and the motor suddenly works, you didn't fix the motor, you exposed the ground problem. If you have power and ground at the motor connector when the switch is on, and the motor does nothing, the motor is highly suspect. But before you declare it dead, consider the mechanical side again, because a motor can be powered and still not move if it's stored hard. Sometimes you'll hear it hum, sometimes it will be silent if it has internal thermal protection or if the brushes are worn and not making contact. If you do not have power at the motor when the switch is on, don't touch the motor yet. That's upstream, fuse, relay, switch, wiring, or a control module output. At that point, the most common real-world culprits are the switch contacts in the stock, a corroded connector, or a broken wire where the harness flexes. Intermittent behavior deserves special attention. If the wipers work sometimes and not others, you want to recreate the failure while testing. Turn the wipers on and gently wiggle the harness near the motor connector. Not violently, just enough to see if the motor cuts in and out. If it does, you found a connection issue. Moisture can creep into connectors at the cowl area, and that location sees water, heat, and vibration. A connector can look fine from the outside and still have green corrosion inside. Now, let's talk about the mechanical system, because it's the silent money pit. The wiper motor doesn't drive the arms directly. It drives a linkage, a set of rods and pivots that translate the motor's rotation into the back and forth sweep. If a bushing wears out, a socket pops off, or a pivot seizes, the motor can spin without moving the arms, or it can overload and blow fuses. A classic scenario: you turn the wipers on, you hear something moving under the cowl, but the arms don't move. That often means the motor crank is turning but the linkage is disconnected. Another scenario: one wiper moves and the other doesn't. That can be a linkage issue, but it can also be a stripped arm spline on the side that's not moving. The difference is subtle: if the linkage is intact, the pivot shaft under the arm will move. If the arm spline is stripped, the shaft moves but the arm doesn't. If the linkage is disconnected, the shaft may not move at all. If you can safely lift the wiper arms away from the glass and try to move them by hand, you're feeding for binding. They should move with some resistance, but not feel like they're glued in place. If one side feels stiff or crunchy, that pivot may be seizing. A seized pivot is a fuse blower and a motor killer. People replace the motor, it works for a week, then dies again because the real problem was the pivot. And then there's the park function. When you turn the wipers off, they don't just stop wherever they are. The motor keeps running until it reaches the park position, then it cuts itself off. That means the motor has an internal switch or internal contacts that manage parking. If those contacts wear or burn, you can get wipers that stop mid-windshield, or wipers that won't turn off, or wipers that only work on one mode. It's maddening because it feels like the stock switch is haunted. Sometimes it is the switch. Sometimes it's the motor's spark circuit. The way you tell is by checking whether the motor is still being fed power when it shouldn't be, and whether the behavior changes when you unplug the motor. If unplugging the motor stops the won't turn off problem instantly, that suggests the motor or its spark circuit is involved. If the motor keeps being commanded on by the car even with a known good motor, that points back to control. Another mistake people make is testing the motor off the car and declaring it fine. A motor can spin freely on the bench and still fail under load. Worn brushes, a weak commutator, or internal resistance can show up only when the motor has to push the linkage through a full sweep. That's why the best test is in the car, connected, with the linkage attached, while you measure voltage drop. If the motor is commanded on and you see voltage at the motor drop dramatically, that indicates high current draw or a supply problem. If voltage stays healthy but the motor stalls, that's a motor or mechanical bind. Let's walk through a few common, you think it's one thing, but it's another, cases. Case 1, you replace a blown fuse, it blows again immediately. The temptation is to keep feeding fuses until one holds. Don't. Repeated fuse blowing is a warning. Either the motor is shorted, the wiring is rubbed through and touching metal, or the linkage is jammed so hard the motor is pulling too much current. If you keep trying, you can overheat wiring. The safer move is to disconnect the motor and try again. If the fuse no longer blows with the motor unplugged, the short is likely in the motor or in the wiring right at the motor. If it still blows with the motor unplugged, the short is upstream in the harness or control side. Case 2, the wipers work on high speed but not on low or intermittent. People jump to bad motor. But often, high speed uses a different part that can mask a failing switch contact or a failing control circuit. If one mode works, you know the motor can run and the ground is probably okay. That pushes suspicion toward the stock switch, the intermittent control, or the specific circuit feeding low speed. Without a wiring diagram you won't pinpoint every wire color, but you can still use logic. Partial function means not a total power loss. Case 3, you hear the motor, but the arms don't move. That's almost never a fuse or relay. That's a mechanical disconnect. The fix might be as simple as reattaching a linkage socket or tightening a nut on the crank arm. But be careful, if a linkage popped off, it may have popped off because the system was binding. If you just snap it back on without addressing the bind, it will pop off again, or something else will fail next. Case 4, wipers stop in random positions. People blame the switch because it's the thing they touch. But the park circuit lives in the motor assembly. If the motor can't reliably find park, it will stop wherever power is cut. Sometimes cleaning a connector helps if the park signal is passing through it. Sometimes the motor assembly is the real fix. Now, what do you actually do once you've isolated the area? If it's a fuse, replace it with the correct rating only. If it blows again, stop and diagnose the cause. Look for obvious harness damage near the cowl, where water sits and where the hood hinges and moving parts can rub. Look for pinched wires after previous repairs. If you find a rub-through spot, repair it properly, not with a twist and hope. If it's a relay and you've proven the relay isn't switching or has bad contacts, replace it. But if the relay isn't being commanded, the relay is not the villain. It's just not receiving the signal. If it's a ground, clean it. That means unbolt, remove corrosion, ensure metal-to-metal contact, and tighten properly. A looks tight ground can still be electrically bad if there's oxidation between surfaces. If it's a connector, don't just spray something and walk away. Inspect for green corrosion, bent pins, looseness, water intrusion. A connector that's slightly loose can pass a no-load voltage test and fail the moment the motor draws current. Reseating it firmly can be a real fix, but if the pins are damaged, it will come back. If it's the stock switch, the symptom is often inconsistent operation across modes, or wipers that only work when you hold the stock in a certain position. Switch replacement can be straightforward or annoying depending on trim and airbag considerations. If you're not comfortable around steering wheel airbag components, that's a good moment to hand it to a shop. If it's the motor, replace it, but only after you've checked that the linkage moves freely. A new motor installed into a binding linkage is like putting a new heart into a body with clogged arteries. It might run for a bit, then fail again. If it's the linkage, you may be able to replace bushings or the whole linkage assembly. The key is to restore smooth movement. After repair, cycle the wipers with the arms off the glass if possible, just to confirm the sweep is smooth and nothing is hitting the cowl. And here's a small but important detail: after any work where the arms were removed, align them correctly. If the arms are installed one spline off, the wipers can hit the trim, park too high, or leave a big unwiped area. That can look like an electrical issue later when it's really just misalignment. At this point, you should have a clear answer to the question that causes most frustration: is the motor dead? Often, it isn't. The motor is just the visible suspect because it's the thing that moves. But the system is a chain, and the chain fails at the weakest link: a corroded connector, a tired switch contact, a loose ground, a seized pivot, a popped linkage socket. If you want a simple mental map, think in 4 boxes. Power in, command, motor, mechanics. Your job is to find which box is broken, not which part is easiest to blame. And if you're still stuck, here are the moments when it's smart to stop and get professional help. If fuses keep blowing and you can't find a mechanical bind, because that can indicate a wiring short that needs careful tracing. If you see signs of water intrusion into a control module area. If the problem is intermittent and you don't have tools to test under load. Or if accessing the switch requires working around airbag components and you're not trained for that. But in the majority of cases, windshield wipers not working on Suzuki Swift comes down to a small set of repeat offenders: a blown fuse caused by binding, a corroded motor connector, a weak ground, a worn switch, a tired motor, or a linkage that's either loose or seized. The difference between a cheap fix and an expensive guessing game is proving which one it is before you buy parts. Once you've repaired it, confirm it like you mean it. Test all speeds. Test intermittent. Test washer function if it shares the circuit. Let the wipers run long enough to complete multiple park cycles. Then turn them off mid-sweep and see if they return to park correctly. If they do, you didn't just get them moving. You got the system back. Because the real win isn't that the wipers move in the driveway. The real win is that the next time the sky opens up and visibility drops to nothing, you flick the stock and the blades sweep like they're supposed to, quietly, reliably, without drama.